One day, Rukia found a fossilized bone in her backyard while she was gardening. Or maybe just eating.
It's such a hot day. Wait a minute. I think that's a dinosaur bone. Let me take a picture.
She believed that bone belonged to some kind of dinosaur, so she did some research on the internet.
Hello, hi and Assalamualaikum. Did you know what are fossils and where they come from? So basically, dinosaurs are insect animals with upright limbs that lived on land millions of years ago during Mesozoic era. When they died, the rest of his skin and the muscle rotted away, leaving only his bones. Then it was quickly buried for millions of years by a different type of mine, and then they will become fossils. For fossils are hard to find in our era. However, fossils still can be traded, and the price is worth the age and the rarity of the fossils.
She read that it is important to know the age of the fossil in order for her to know how much money it's worth. Hence, she asked some help from her daughter.
Found a dinosaur bones, I guess, in our backyards. So I've been reading about it, and it states here that the older the dinosaur bones, the more money that we can get if we sell it to some kind of, I don't know, fossil specialist. Yeah, sure, Mom, I can help you with that. But are you sure it's a dinosaur's bone? Could you take a look at it, please? Like, it looks like a dinosaur head.
Yeah, it does look like a dinosaur's head. I will try my best, Mom. If moms want to know the age of the fossil, I should know the half-time of the fossilized bone. Let me think. A fossilized bone is found to contain 1/1000 of the original amount of radioactive carbon C14. If it is given that the half-life, it should be half-life, not half-time. So the half-life of C14 is approximately 6,750 years. So I need to determine the age of the fossil.
Let's go through the introduction. Half-life. Half-life is defined as the amount of time it takes for an atom to decrease to half of its initial value. In ordinary differential equation, we use a separable different equation application to calculate half-life. We can also use the application to calculate how long it takes a radioactive substance to decay and the age of the substance that contains a radioactive substance.
I will explain about the calculation. Let A be the amount of radioactive carbon-14 at any time t. Since the question does not give the initial amount to disintegrate, we assume that A0 equals to P0, where P0 is the original amount of radioactive carbon-14. Another information that we get from the question is AT equals to 1/1000 times P0, since it stated that the fossilized bone contained 1/1000 of the original amount of radioactive carbon-14. One more information is that the half-life of carbon-14 is 6,750 years. Therefore, A 6,750 equals to 1/2 P0, since it is the half-life of carbon-14. We derive the equation AT equals to CE to the power of KT. To determine C, T equals to 0 and A equals to P0. Next, we substitute in the equation AT equals to CE to the power of KT become P naught equals to CE to the power of K times 0, and we get C equals to P naught. We rewrite the equation AT equals to P naught e to the power of KT. Next, we use another information to determine K, where T equals to 6750 and A equals to 1 over 2 times P naught. We substitute in the equation of AT equals to P naught e to the power of KT, and it becomes 1 over 2 times P naught equals to P naught e to the power of K times 6750. P naught from the left hand side and the right hand side can be cancelled. Hence, it becomes 1 over 2 equals to e to the power of 6750 times K. After that, the exponential from the right hand side move to the left hand side and become ln 1 over 2 equals to 6750K. We will get K equals to negative 0.0001027. Rewrite the equation of AT equals to P naught e to the power of negative 0.0001027 times T. Lastly, we use the last information, which is AT equals to 1 over 1000 times P naught. We substitute in the equation of AT equals to P naught e to the power of negative 0.0001027 times T, and becomes 1 over 1000 P naught equals to P naught e to the power of negative 0.0001027 times T. Both P naught from the left hand side and right hand side can be cancelled. Therefore, it becomes 1 over 1000 equals to e to the power of negative 0.0001027 times T. We move the exponential from right hand side to the left hand side. Hence, it becomes ln 1 over 1000 equals to negative 0.0001027 times T. Lastly, we get T equals to 67,261.49 years, where the final answer is the age of the fossil.
In conclusion, radioactive decay, which is half-life, are mathematical change. Experimental evidence show that the radioactive material decays at a rate proportional to the mass of the material present. The constant K need to be negative, which implies that the mass is always decreasing. What we have learned from the problem statement that first-order equation are applied to solve the numerous problems in real life, including those involving radioactive decay. As a result, we found that the age of the fossil is 67 and 261.49 years after applying the first-order differential equation. The longer the half-life of a substance, the more stable is it. That's all from us. Thank you.